There we go. So welcome to this episode with me, Martin Franson, that runs Welledge in Old Town. And today I had the honor to have with me Dr. Robin Pauc, who's a fellow chiropractor, also a graduate for ACC, although you graduated many years before me. I think it was 74, I graduated 96. Much has happened after that. But you also into the area of functional neurology, and you are actually an associate professorship at the Carrick Institute. Yeah.
Correct.
And not only that, you published articles, you published books for parents and to learn more about delayed brain syndromes that we're going to look into in this episode today. And you also, you not only that, but you have your own way of helping parents and children on the spectrum and moving away from this traditional diagnosis that we put, that you've been very clear, moving away from these syndromes to looking at them as symptoms and looking at them as what's going on in the brain, and therefore how can we actually address them with specificity and get results that I know that you get in your clinic in the New Forest, the Tinsley Clinic. So we're going to come back to that, how to reach you in the end. But I'm so grateful for you taking the time, and I hope to see you.
It's a great pleasure. Good to meet you again after all this time.
Yes. So let's start up with, all over the world, at least as far as I know, in the Western world, it's becoming more and more prevalent that children get this diagnosis, whether you call it ADHD, ADD, autism, dyslexia, dyspraxia, dyscalculia, OCD, Asperger's. You have all these varieties of abbreviations, and you have put forth a different model how to look at this, as I mentioned, and the comorbidity aspect of it, that not one child is the same, and it's rarely that they have one of these issues. It's more than that.
Yeah, back in 1952, which is a long time ago, they came up with this thing, the DSM-5, well, the DSM-1 then, but it's now DSM-5. And it was a system of how to diagnose neuropsychiatric disorders, but including disorders of childhood. Now, they've had edition after edition after edition, and each one has been criticized because all it does is ask questions. Depending on the answers, you're put in a box, and that's that, you're diagnosed. Well, if that was followed by effective treatment, that will be really, really good. But it's not. And what tends to happen is every now and then, something becomes in vogue, it becomes popular. And at the moment, endless kids are being diagnosed as having ADHD, autism. And the thing about it is that ADD, ADHD, they're not looking at the cause, they're just looking at what you see, the signs, the symptoms. And if we move on to autism, there's nobody on the planet that knows when autism starts, why it starts, what it affects in the brain, what you can do to change it, alter it, make it better. And yet endless people are being diagnosed, children are being diagnosed. And the weird thing is that loads and loads of adults now are saying, I'm autistic.
Yeah.
If it were a condition where you could have a blood test or whatever, and they could say, aha, yeah, you've got raised this, you've got raised that, you're probably autistic. That would be one thing, but nobody knows what it is. Now, if we look at ADD, attention deficit disorder, or attention deficit hyperactivity disorder, the thing is that they keep changing the titles. If you look at the DSM, 1 minute Asperger's is a condition, the next minute it's not, it's part of the autistic spectrum. Now, there's total, I would say, ignorance. People are not thinking about the situation as it is now. Things have moved on since 1952. We know a lot more about how the brain works, how it functions, why it can go wrong. And yet people are sticking with this book. So if we look at attention deficit, is it attention deficit or is it vigilance?
Yeah. Mm.
Right. Now, our brain, when it's growing and developing, has to go through all the stages we went through in our evolution. Now, way back in time, we were hunter-gatherers. Now, if you're on the plains of Africa hunting, you're in the moment and you're focusing on catching something because, your group, your clan, your family depend on that food.
Yeah.
But you also have to be hyper vigilant because something could be creeping up on you and you could become lunch for some wild animal.
Yeah.
Now, that is vigilance, is not attention deficit, because you have attention deficit on the fields, the plains of Africa, you're going to die very quickly. And so we've got a child that's going through this Paleolithic stage of development and is hypervigilant, has to look at anything that moves. We put them into a busy classroom and we diagnose them as having attention deficit.
Mm.
It's because the people who are making these diagnoses don't understand how the brain functions, how it grows, how it develops, and the stages it goes through. And if you think about it, it was only when we became farmers in the Neolithic period that we needed things like time, quantities, numerosity, because all of a sudden we're planting stuff and we can't say, well, I'll go off and have a cup of tea and come back and harvest. We've got to plan months ahead.
Yes.
Because that's how long it takes to grow the crops, the cereals. But also we need to know how much we need to plant, because we're not going to be able to harvest and harvest and harvest because we've got a time scale, a window of opportunity.
Yeah.
So we have to be able to understand time and understand quantities, because if you plant not enough food, you've got to wait another year because you can't have a harvest now.
Yes.
And so we went through a Paleolithic period, we went through this Neolithic period, and now we're going through a very strange period that's dominated by technology. And we're not looking at the brain and how it normally grows, develops, matures. We're just looking at signs and symptoms, glitches in its development.
Yeah.
And so it's by understanding these things that we can actually get effective treatment. So going back to attention deficit, is it visual inattention, where bits of the brain, so back here we've got what's called the magnocellular area, you've got it on both sides, but the right side has to become the executive. And its job is not to see as in I can see you, it is to detect movement in your periphery.
Yeah.
Because if something's creeping up on you, you've got to be aware of it. So has this child got visual inattention, or have they got mental inattention where they just go off somewhere?
Yeah.
Because the work's too hard, it's boring or whatever, and so you go off to a better place in your mind. If I split the brain open and we look at the medial wall, this is where we have mental inattention, daydreaming. And fantasizing, daydreaming is a right brain activity. Now, if we just class attention deficit as just being one condition, we're missing the point, because it could be visual inattention, it could be mental inattention. So if we can pinpoint what it is and where it's coming from, then we've got a starting point for treatment.
Yeah.
But just saying, Martin, you've got attention deficit or you've got ADHD, the logical question to follow on will be, well, what are you going to do about it?
Yeah.
But most of these educational clinical psychologists will just say, well, I've told you what the problem is. Maybe occupational therapy would help, maybe some physiotherapy. We could consider drug therapy. But if you don't know what's causing these symptoms, how can you possibly treat it?
Yeah.
Does that seem to make sense?
Yes, it does.
But we're thinking about it in terms of old-fashioned psychology, as opposed to not just modern neurology, but functional neurology.
Exactly.
How the brain actually works in terms of its neurotransmitters, neuron fields, etc.
Yeah. And your way, as well as mine and others that work with functionality, is looking at, okay, what stressors has the person been exposed to in the womb or during delivery or during the first period in life, whether it's chemical, physical, emotional, that can put, that stressors can cause what you has called DDS, developmental delayed syndrome, that parts of the brain are not developing as
it's quite interesting. There was a gentleman, I can't remember his name, he lived in the north of Sweden, and he collected data on not just birth, deaths and marriages, but also on the weather, on harvests and whatever. So he had all this data, and for some reason he was going to retire, and he contacted someone, I think at Cambridge University in the UK, and said, look, I've got all this data. It goes back for donkey's years. Would you like it? And the guy said, yeah, brilliant, fantastic. And what they picked up was there was a relationship between hardship, as in famines,
yes,
and symptoms that would progress. And it went through generations. And following 9/11 in America, a research team found women who were at 9/11 in the thick of it, not watching it from on the telly, and said, look, you're pregnant. Can we take a swab from you when you give birth and a swab from your baby, just a bit of saliva? And they've done this, and they found that in the mothers and the newborn babies, they both have raised cortisol levels, an indicator of stress.
Yes.
Now, this is a long-term study, so they're now waiting for the babies to grow up and have babies to see if the grandchildren have raised cortisol levels. So what this is we're imprinting genetically and carrying things over. So we have to look at the family history and see if there are any stressors that raise the probability of there being a problem. We have to look at the history of the pregnancy. We have to look at the labor. We have to look at the delivery, all these factors. And way back in time, I wrote a paper on fetal distress. And these are important factors which are often overlooked.
Yes.
Now, if the baby, it's hard enough being born, if you think about it. You're in a nice, comfortable environment. Then all of a sudden, you're squeezed through the funnel and out you come. Well, if you're a big baby, if you're in the wrong position, if the cord's around your neck, if they need to intervene with suction, forceps, whatever, it's a very stressful situation. And a number of children actually suffer as a consequence. They have a lump on their head from the ventouse, or they have marks on their face from the forceps. So it's not a pleasant experience, and that can stress the brain. Now, the control of the growth and development of the baby in the womb and thereafter, because you've got to get from this size up to your size, something has to control that growth and development. And that, we know now, is due to the epigenome.
Yes.
So a while back, the whole science of epigenetics came up, and we know that the epigenome controls everything. So the epigenome talks to homeobox genes that talk to other genes and say, right, we need to grow ears now, we need a nose, we need limb buds and whatever. So that controls the growth and development in the womb, but it also controls it from that day on. So once you're born, you've got to grow up and become a woman or a man. Now, the evidence would suggest, and there's evidence from different parts of the world, that if there's a stressor, it can cause the epigenome to glitch. It's not broken, it's just not working as well as it should do. And then bits of the brain don't develop as they should do. And therefore, you see signs, because most of the brain works by one area inhibiting another area. And so this inhibition or lack of inhibition causes brain activity. So a stressor affects the epigenome, and then you end up with a delay in development, not a condition. Because people think, take the word dyslexia. When dyslexia was first, brought into being, a man was looking at children with normal eyesight, normal intelligence, but was struggling to read. And he didn't know why.
Yes.
But he called it, being an educated man, he switched it from being German as he spoke, over to Greek, and he called it dyslexia. Well, if you translate it back, it's struggling to read disease, which is stupid. You know, it's rather like me going to the doctor and saying, I've got a most terrible headache. And he says, oh, you've got cephalalgia. And I say, oh, thanks, great. And he gives me some pills and says, off you go. Well, he's just told me I've got a headache.
Yes.
And we hide behind these, you know, Latin, Greek names and think that we've actually diagnosed something, but we haven't. We've only told the person what they told you.
Yeah.
And so we need to get rid of these terms that we use, dyslexia, dyspraxia, attention deficit, because they're not conditions in their own right. They're just signs and symptoms of a brain that's glitched. Yeah. If we can track where it came from, then we, you know, that's the starting point of treatment.
Yeah, and that's the wonderful thing of it, because for so many parents and people that gets these kind of diagnosis, it's like, oh, that's hereditary, you know, this is your genetics, this cannot be changed, this only medication that's going to help you in this. There's no other solution. But when it's epigenetic, you can address it. And when you know which part of the brain that needs retraining, you know how to rehabilitate your brain. And
I mean, this is one of the problems, that people are still saying that once you've got it, you've got it. It's there for life.
Yeah, and it's not.
And it's not. It's purely that you don't understand what is happening, why it's happening, where it's happening. Yeah. Once you do, you can say, right, well, that's coming from the magnocellular area, the parvocellular area, the anterior cingulate. So you know where you've got to go to treat it, to address the issue.
Yeah, and to exercise, and there's varieties of treatments through that you use with.
It has to be holistic, because basically you've got to look at diet. You've got to think about supplements, because the brain is growing rapidly and it may need help with omegas, zinc, magnesium, whatever. If it's the cerebellum that's causing a problem, because this little fella at the back here, at the back of the brain, this has been ignored for donkey's years. Everybody's focused on this bit because it's the biggest bit. Yeah. This has been ignored, but you have to sort this bit out before you do anything with cerebral hemispheres. Yeah. We'll perhaps come to that a bit later on.
Yeah, definitely. But
we have problems in how we approach the whole thing.
Yeah.
And it's down to, I don't know, familiarity. I've said in writing, can't remember where I wrote it, but I wrote it somewhere, that we've got into a very deep rut. And the rut has got so deep that we can't get the wheels of the cart out of the rut.
Yeah.
And also, I suspect there's a lot of sort of vested interest in carrying on where we are, because the DSM sells worldwide, psychologists, all these people who diagnose children, that's their job, that's their income. Yeah. And they're going to be very reluctant to say, I've got to retire now. Listen to what Pauc says. So there's a lot of resistance to change.
Yeah. That's for sure. And you used it really nice that we've gotten down in these tracks, this rock that is said, but it's also a nice way to look about the development delay syndrome, that, if you're right-handed, you tend to keep doing your right hand. I mean, the way the brain develops and these traits that we now label in different ways is the way that the brain has learned to handle things. And it's tricky for it because it costs energy to start using it in a different way, to start using those parts of your brain that's not as far ahead in development. That takes energy and it takes focus, and you need to pinpoint how to address that more specifically. Then you can get the brain out of the rut and make it flourish and work as a whole unit.
But also, you were saying about handedness. Basically, if you look in the textbooks, they will tell you that the left cerebral hemisphere develops before the right. That's why most people are right-handed. There was an interesting paper written a few years back, and I think it was a German researcher, was looking at scans of babies in the womb.
Yeah.
And a lot of them were sucking their thumbs.
Yeah.
And he thought, how's that possible? Because the brain isn't physically in contact with the arm at that stage. So how could the brain be saying, do that, to do it accurately, to actually get the thumb in the mouth? And he decided, after doing some research, that it was the spinal cord, probably the central pattern generators, that actually do it. So it's a local thing rather than coming from the brain. So although the left brain, right cerebellum does tend to develop before the right brain and left cerebellum, it is the spinal cord that probably decides handedness.
Interesting. Because, I mean, sucking exercise is a variety we tend to give for enhancing convergence, getting the eyes to focus together for dyslexic. Well, I'm not going to use the words, but when you have the reading difficulties.
I mean, you see, it is so difficult to stop using these words.
Yes.
So we've gone through a stage now where we've become very politically correct, and probably some of that is right. But historically, dyspraxia was called the clumsy child syndrome. Because the child was clumsy. So they had problems with gross motor skills, fine motor skills, hand-eye coordination, spatial awareness. Now, if you think about that, which bit of the brain is key to controlling all those functions? So if we just talk about dyspraxia, well, what is it? Is it general dyspraxia? Is it dressing dyspraxia? Is it fine motor skill dyspraxia? It's silly. It's like me saying, if you said to me, have you got a motor car? And I said, yes. And you said, what have you got? And I said, I've got a red one. You say, well, could you tell me a little bit? Oh, it's a Citroen, or it's a Porsche, or it's a Ferrari. Right? So it's silly having this term car when you really want to know it's a Mercedes, it's a Saab, it's a Volvo, whatever. I chucked in a few Scandinavian cars there so you didn't feel out of it.
Well, let's then, when you're talking about that, let's bring in your these and in your publications and your book as well about development delay syndromes and all these, labels and the comorbidity. I mentioned it in the introduction of you, how essential that is, the comorbidity, understanding that it's rarely that, when you fix one label, you go through and this child is dyslexic or this child is ADD. But it's not. It's the comorbidity. All this.
The problem is it's human nature. You bring your child to me. I'm an educational psychologist, and you say my son is struggling to read. So what am I thinking immediately? Dyslexia. You come to me and say, "This is my son. He is so clumsy. It's unbelievable." Dyspraxia. Right. So we think about these labels because we just want to put the child into a little pigeonhole. Because once I've done that, I've done my job. I don't have to do anything more other than give you a name for the condition, supposed condition your child has. So anyhow, way back in, before 2005, because I had a paper published in 2005. But before that, I became very interested in what are these things? And one day I was sitting down, I won't tell you where I was sitting down, but I was sitting down and I thought, supposing they're not actually conditions, they're just signs and symptoms. Right? And that makes more sense because there's a similar situation now that if you went to your doctor and he happened to say, right, while you're here, we'll check your blood pressure. And he said, oh, your blood pressure's through the roof. We'll give you medication. What he should be saying is, I wonder why your blood pressure's up. Because having hypertension isn't a condition, a disease. It's a sign that something's wrong. And so I had this thought, supposing they are. And so I looked at all my patients in far greater detail. And rather than focusing on the obvious, this child's struggling to read, they're dyslexic, I looked at everything else. And developed a questionnaire where I could say, does your child do this? Does your child do that? Has your child struggled with this? So I look at everything. So family history, pregnancy, labor, delivery, developmental milestones, academic stuff, motor skills, social skills, everything the child does, their diet, whether they take supplements, everything. Because if I do that, I can then pinpoint exactly where in the brain the problems are coming from.
Yes.
But if I just simply say, all right, yeah, you've got dyslexia, where do I go next? How do I treat it?
Yeah.
And so it was that. So I wrote this paper, which was published in 2005, and we're now in what, 2023. And people on a daily basis around the world are still looking at that paper and citing it.
Yeah.
Because all of a sudden, I don't know, how many years is that from 2005 to now? It's a lot.
Yeah.
Right? But people are now, and it amazes me because I belong to a thing called academia, and every week they tell me who's been looking at my papers. And I look and I see Auckland, Cuba, South Africa, Sweden, UK, America, Canada. And people now are suddenly thinking, hey, maybe he's right. Yeah. Maybe this, these things aren't conditions, they are signs and symptoms. Yeah. And that makes a huge difference, because once you start thinking like that, if you've got enough neurology, you can actually say, well, that's probably coming from there, that's coming from there, that bit talks to that bit. Yeah. And so when I'm teaching, one of the things I do is go through a very detailed list of functions of the brain. Yeah. Not just talking about bits of the brain like the parietal cortex, the occipital cortex, but subsections of it, and within the subsections, neuron fields, and even down to the type of neurons that are doing stuff. So things like von Economo neurons, calcium binding calretinal cells, all the different sort of neurons that we have. Because if you know that it's the calcium binding calretinal cells that are playing up, or the cells in the anterior cingulate are under functioning, whatever, then you can say, right, that's where we need to treat it. How can I get at that bit of the brain? Yeah. So I might have to go from one bit of the brain to another bit of the brain to another bit of the brain, but I know I can find a pathway that will get to the anterior cingulate, will get to the magnocellular area. And so you can then provide effective treatment if you actually understand the underlying cause. Yes. Yeah. It sounds a better way to me than just saying, well, you're dyslexic, so I'm going to pop you in that little pigeonhole. Yeah. Yeah, exactly. Because 20 years later, you're still going to have dyslexia. Yeah. Yeah. But the only thing you've gained is a so-called diagnosis. Yeah. Let's... that when we talk about treatment to people, to understand that that's to a very broad extent, you're using dietary plans, supplements, as you mentioned, exercises, different stimuli through, movement, touch, and visual and auditory, and computer programs that address that as well. Yeah. But you are a chiropractor and working from a functional neurology perspective. Yeah. So that's all I do now. I only do functional neurology. Yeah. So my days of being a chiropractor are pretty well over. Yeah. But going back to what you were saying, if we look at diet, there's more and more concern now about the modern diet. Now, several years ago, they came up with this idea of E numbers. Yeah. So this is the chemicals that legally you can add to food. Yeah. And it varies from country to country as to which of those E numbers are allowed. Now, all the E numbers were tested individually and said safe, 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 safe. And then a few years ago in university, not far from me here in Southampton, they said, well, what happens if you mix them? So let's get some popular colorants that children have in their sweets and a popular sweetener, aspartame, mix it all up and see what we get. And we end up with a neurotoxin. Yeah. Now, some other research that was done suggests that as adults, we eat between 7 to 9 pounds of assorted chemicals a year. Yeah. Now, if I was sat here drinking schnapps right from the word go, soon as the glass was empty, I filled it up again. By now, people will be thinking he's not talking very clearly and he's talking nonsense and whatever, right? And it's obvious, the reason is I'm drinking the schnapps. But if I'm eating pounds and pounds, kilos of assorted chemicals a year, is there going to be a problem? Yes, there will. Insidiously, my development will be affected. Recently, just last week, there was a paper published suggesting that the IQ generally is dropping now.
Yeah.
And they're saying it's probably due to food additives.
Yes.
So you have to look at the child's diet, not just, in terms of, is it processed food, is it fast food, but also are they getting protein, fat, carbohydrates? Are they getting vegetables, fruit? Are they getting roughage? All this sort of stuff. You also have to look at when they eat. Breakfast is important. Do they have a mid-morning snack, lunch, afternoon snack, evening meal? Where do they have that meal? Is it with the family, in front of the television? What? And then, of course, computer games. Kids play computer games. And we know now that if you play computer games for half an hour, it's very good. It's positive. If you do it for more than that, it's negative because it affects a part of the anterior cingulate where we hyperfocus. And would you believe that's right next to one of the addiction centers of the brain? So we have to think about lifestyle, diet, what children get up to in their social life. We have to think about supplements because with things like zinc and magnesium, only 20% of ingested zinc gets into the body. And this bit of the brain here, which is the anterior cingulate, uses huge amounts of zinc and magnesium. Now, the anterior cingulate, the dorsal lateral convexity, and a bit in there that you can't see called the anterior insula, together form what's called the frontal hub. And the frontal hub is what makes us human. So if I was rude to you, which I would never be, sir, but if I were to be rude to you, you would have the ability to stop and think, why is he being like this, right? So you'd think about it, come up with something, and then say to me, Robin, why are you being so rude? It's not like you. Right? Now, where I live with the donkeys and the ponies and the cattle, if I go up to one of them and poke them, they don't suddenly think, oh, he's in a bad mood today. I wonder who upset him, right? They would either bite me, kick me, or back off. So we have a handbrake between stimuli response. And the anterior cingulate is where the handbrake lives. So we need zinc, magnesium, apart from other things, to try and get that bit of the brain working as it should be. So we have to look at all these things, diet, supplements, and then specific physical exercises for this thing here that's been ignored forever, when it's in fact, it's the most important part of the brain. And then computer programs which are designed to specifically stimulate the bit of the brain that's causing the problem. So if you're struggling to read, you need to get this bit in here, the paravermal zone of the cerebellum working better. If you've got poor visual fixation, you need to get this bit working better. If you're struggling with spellings, you need to get the parvocellular area working better. And so it goes on. And so if you don't understand the neurology in detail, you can't put the treatment in place. But when you do put the treatment in place, it is really, really effective.
That's what we get to next. How the results, the success rate. I mean,
okay, so there's two problems. One, there's the child that is in their teens. So sometimes people will ring up and say, I've got a 15-year-old boy, blah, 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 blah. And I say straight away, will they be compliant? Because there's no point wasting time and money. And then he says, I'm not doing it. Right? So, and the second problem we have is parents who think they can just wave a magic wand. I'll book an appointment with Robin and everything will be fine. And then when you talk to them, so I see kids every 2 months, you talk to them 2 months later saying, are you doing this? No. Are you doing this? No. Are you doing this? No. Oh, we started it, but then we stopped. We forgot, right? There's no magic. So the treatment regime has to be followed on a daily basis,
Yes.
and it works.
Yeah.
If I could just mention one last thing, which I think is crucial to understanding the brain and its treatment.
Yeah.
Everybody thinks that this is the brain, and this little thing at the back has been ignored. In 2014, a lady, I think she was living in South America at the time, she contacted people around the world and said, this 100 billion brain cells that we have, where did that number come from? He said, it's always been there. So she went off to a laboratory, got some brains, converted them into brain soup, added a dye that only links to neurons, and then used a very clever machine to count them. And we haven't got 100 billion, we've got 86 billion. That's still a big number.
Yeah.
And you would imagine that they're all going to be in here.
In the grey matter, yeah.
80% of those brain cells are in here, the cerebellum. There's only 16 billion brain cells here.
Yeah.
More on the right than there are on the left. Now, the two sides of the brain can only communicate through here, the anterior commissure, posterior commissure, but that's really limited. It's this. Yeah. And there are only a few million, not billion or trillions, million fibers here, which are unidirectional.
Yeah.
So how do the two sides of the brain communicate? It's very limited going through the corpus callosum, but this thing here, this is the computer that drives this side of the brain. This is the computer that drives this side of the brain. Yeah. So this thing we've ignored for forever actually is the brain.
Yeah. Yes. So let's touch more on that, the three brain model, as you're talking about now, because the cerebellum has been looked at as it's just like movement and how we develop our motor skills and balance and so forth. But and then it's more and more research has been showing it's involved in everything. It's a modulator for effective behavior and so forth. And you know, we talk a lot about the prefrontal cortex and so forth, but the cerebellum has been like, but more and more brings it up on the table.
Yeah. Back in, I think it was 2018, there was a big conference in Japan. And as I mentioned earlier, one of the buzzwords nowadays is hubs. We've got the frontal hub, the insular cortex, the anterior cingulate, dorsal lateral convexity. So that hub makes us human. But we've got hubs all around the brain. But the conference in 2018 said the cerebellum is the master hub. And that's the way we've got to think now, that it is the computer, using modern language. It's the computer that drives what we think of is the brain. Because if you've only got 9 billion and say 7 billion here, compared with 68 billion, it's pretty limited in the processing it can do. And if you've only got a few million connections from the two sides of the brain, and bear in mind that the two sides of the brain are only connected by here in the little anterior and posterior commissure, and here is a wall that separates them. Similarly, with the cerebellum, there's a roof over the top of it separating. So the three brains live in little rooms on their own. And the most effective communication comes from the cerebellum to the brain. And so we need to think differently about how the brain is structured, how the brain functions. But so many people do their research work in isolation. And I was talking to a professor just the other day, and I was talking about Wernicke neurons. And she said, what are they? And I said, and then sort of went through a long sort of thing about them. But Wernicke neurons were discovered decades ago. They were rediscovered by Wernicke and Momo. and then they were forgotten, and then they were rediscovered by Esther Nimchinsky in 96 and 99. And then the floodgates of research opened, and we suddenly realized how important they are, because they only live, as far as we know now, in the frontal hub. So why would you have this amazing, the latest cell to have, neuron to have developed in just 3 places in the brain? So if you don't know about these details, you can't have a clue as to how the brain functions. Similarly with, I think it was in 2005, maybe a bit later, Patrick Hoff discovered that there are calcium-binding calretinol cells in the front part of the anterior cingulate. And the suggestion was, right at the start, that they may be to do with non-mimetic facial expressions, real facial expressions, and the primitive sounds that we all make. We can communicate without words. So if you would be kind enough as to give me a really nice glass of wine, I would go, Now, I'm saying that's delicious. If I went, right, that's disgusting. So babies and mothers talk to each other without words. Lovers talk to each other without words. A lot of what, little signs and sounds that we make are communications. That comes from that part of the brain. And so if you don't know about these little details, gigantopyramidal cells, magnocellular cells, parvocellular cells, if you don't know about these details, you haven't got a clue about how the brain really works. And the 3-brain model is a very good way for students to learn about brain function, simplify it. There was a writer, a Jesuit priest, who wrote loads and loads of books, but he wasn't allowed to publish them because he was a Jesuit priest. But when he died, his friends got hold of the manuscripts and had them printed. And one of his strengths was he could have mental models that couldn't happen in reality. Well, they probably will in the future, but not at this present time. But they just allowed you to see something, to think something. And if by having the 3-brain model, you can simplify neurology and get people to better understand what's happening.
Exactly.
So when I'm teaching, one of the things I do is teach people that the brain only works in virtual reality. We guess a lot of what we're seeing, what we're hearing. We don't actually really see things. We only do if we're in an emergency situation. So I teach them that, but I also teach people how the brain is, well, putting it simply, the right brain deals with everything new, everything emotional, everything defensive. It's the side that fantasizes, oh, this is so boring, and you float off to a wonderful holiday resort in your mind. Left brain, most people, speech and language, mathematics, science, all the clever stuff. But it's reliant upon the right brain. Now, because the left brain and right cerebellum develop before the right brain and the left cerebellum, if there's going to be a developmental delay, in the vast majority of cases, it's because the right brain, left cerebellum is under functioning. And there's very simple neurological tests that anybody could do that will tell you, the left cerebellum's down. And then there are other tests you can do, and you think, the right cerebral hemisphere isn't behaving as, at the speed it should do.
And these tests are in your books. I know at least in Is That My Child? I don't know the latest one, The Myth. I just got that yesterday. Because
I don't know. I've never read it.
But you in your books, you do give parents a lot of guidance to find out for themselves as well as for their children, and guidance to what they can do on their own and see whether that works, tests and supplement suggestion, diet plans and so forth. I mean, you even have the brain diet plan book, so to give self-help, so to speak. And with that, on top of that, you can supplement with reaching out to you, the Tinsley House Clinic in the New Forest, not between Southampton and Bournemouth. And there are other functional neurology practitioners. I mean, I run here in Stockholm, Old Town, and there are more and more all over the world. I mean, there's many people that you train. You're going to soon start up a new training as well. That's going to be interesting.
Yeah, I've got a new one starting in May. So that's I do 5 weekend modules. So it's pretty tough. You do all day Saturday, all day Sunday, but then you go away for 2 months. I can do some of it virtual, some of it you need to be here. Yeah. But you then go away. There's textbooks that have been written specifically for the course. And so you get homework to do. You've got guided study and whatever. And so by the end of a year to 16 months, it depends on whoever the people are that I'm teaching the students. Yeah. So sometimes I do modules for people like special needs coordinators. Other times I do it for practitioners. It just depends on the level. So I might do 5 modules, I might do 6, but it goes into the functional neurology in quite a depth. And you end up at first thinking, I'm never going to learn this. And then within sort of 2 or 3 modules, you're sprout, all these words are coming out and whatever. Yeah. So, yeah, it's good. So sometime in May, we haven't finalized the starting weekend yet.
Yeah, but it's coming. And I'm going to put below here information about your books and how to reach you, your website and about your clinic and so forth. So people that listen and see this can reach out and find out more and get access to your books and publications. And I do looking forward to get you to invite you to come to Stockholm. I mean,
I'd love to, because
20 years ago since you were here. And
it can't be that long, so I'm not that old. Yeah, it'd be lovely. I think coming to Stockholm was fabulous, because also when I was there, I had the opportunity to go to the north, to visit a friend and to see the northern Sweden. I just loved it. Yeah, I like things like sort of wilderness, snow, deserts, whatever. I think it makes you feel alive rather than being in a town or a city. Just lots of space.
Yeah, well, you have that in your forest. You have that. You have the forest, but you also have a lot of open areas in.
Yeah, we have what are called enclosures. So. Yeah. That's enclosure spelt with an I, because it's not to keep animals in, it's to keep animals out. Yeah. And so we have protected areas so the cattle and the ponies can't get in. Yeah. And then we have other open areas. And probably when we finish talking, I'll get my little dog, go and pick up her boyfriend who lives a mile down the road, and then go off to the woods and have a walk.
Oh, wonderful. Wonderful.
We've got very strong wind here today, so it's 40, 50 mile an hour gusts. So we'll see. I don't want to get blown away.
Here it's snowing and -1 or 2. Yeah, so it's winter here in Stockholm.
Well, that's not too bad.
So any final words, tips, suggestions to parents, adults?
Well, to parents. Have a look at the books, because the myth, the latest one, is an update on the Is That My Child, which was 2005. So that's the most up-to-date book. And it also contains suggestions, because what I like to do, because I've got to an age now where I can upset people and get away with it. And so what I like to do is sort of pose little things. And it's quite interesting, because there's been a debate going on for years, and quite an angry debate, about is there a male brain, is there a female brain? Yeah. And just recently, a professor in America said that if you're doing research, you must state the gender of the brain. Yeah. Now that's good, because it'll make people think, well, is there a female brain, is there a male brain? And it's obvious, because the male cerebellum is 14 to 18% bigger than a female. The amygdala buried in here, bigger in the male.
Yeah.
But the connection between the two, the anterior commissure, is bigger in the female brain.
Yeah.
There's a greater neuron density in the amygdala of women. Speech and language centers are bigger in women. The use of neurotransmitters in this base area of the brain, in the region of the nucleus and main heart, completely different in males and females. It's even been postulated that there's a homosexual brain.
Yeah.
Some of, partially female, partially male.
Mm.
There's evidence, which needs looking at again, to suggest that regardless of your body, you can have genetically be a man or a woman, but you could have the opposite gender brain.
Yeah.
Now, that is more than possible, and that needs to be looked at. And so I'm just out there saying, I don't care if people throw stones at me or whatever, because it needs to be looked at, because there's a lot of people talking about, transgender stuff and all the rest of it, but there's no science behind it. You need science behind it. So I can say, this guy, obviously a male, he's got male genitalia, but he's got a female brain.
Yeah.
This girl, beautiful young lady, but has a male brain.
Yeah.
And then we'd have a far better understanding. But just sort of saying, oh, you're just a bloke who wants to dress up in ladies' clothes, you're weird, you're odd. That is so ignorant. And we need to look at the brain in far greater detail. So one thing is, for parents, look at the books, because there's the myth, there's the dietary guidelines in other books. Contact me, ring me up or email me, talk, because advice is easy to give. And if you're really concerned, then I do Zoom consultations around the world, so I can help wherever you are. And if you're a practitioner, contact me. This course starts in May, and I think there's three places left.
Great. Yeah. Wonderful.
It's been lovely talking to you again after all this time.
Yes, indeed. And looking forward to continuation.
You said 20 years. It only seems like 5 minutes ago.
It's all in the brain. It's all in the brain.
It is. You take care.
The same. I will end the recording here and can talk a little bit after. Just thank you ever so much. And please, if you have liked this, whether you listen on the pod or on the YouTube, please like it and share it forward to others that I need to get this information from Dr. Robin Pauc at the Tinsley House Clinic in New Forest. Thank you.